All right. In this lesson, we are going to look at how we can write linear equations through reading and analyzing word problems and then solve them through different algebraic methods. So this is our systems of equations lesson on word problems, basically. So for the do now, take a moment, see if you can solve this system algebraically. That means either using substitution or elimination, and take a moment, get that done. Alrighty, I'm going to start copying down these two equations. I'm going to start copying down this system, and I'll solve it using, I think I'll probably solve it using elimination, though either way really would work. Substitution kind of works too. All right, so I've got it copied down. Let's go over to the camera. So 4x minus 9y equals negative 11. 3x minus y equals 9. I'm going to solve this by doing elimination. The substitution could really work because all I'd have to do is just get this negative and 3x away and then plug the y in, but I like elimination. So I see a 3 and a 4. That's going to be kind of weird to get those to be able to eliminate. So I'm going to look at this negative 9 and this negative 1. If I just say, hey, I can take this whole bottom equation and multiply a negative 9 across everything, this negative 9 times the negative 1 would make it a positive 9. Those are set up to eliminate. So let's do it. Distribute those guys all over there. Negative 9 times 3 is going to be negative 27x. The negative 9 times negative 1y becomes a positive 9y, which is what we wanted. Now those are set up to cancel. Negative 9 times positive 9 is going to be negative 81. And now I'll bring this whole equation down just to be able to see exactly how that elimination is going on. All right, so negative 27, I can just add straight across. Negative 27 plus 4 is going to end up as negative 23x. These two cancel out. That's the whole reason I did that multiply by negative 9. So these were ready to eliminate. And then negative 81 plus negative 11 is going to be negative 92. And now I can divide both sides by 23, by negative 23, I mean. X is going to be equal to, let's grab a calculator super quickly and do negative 92 divided by negative 23. I end up with x equals 4. We're almost done. We're just going to take this x and plug it back into one of my original equations. I'm going to plug it back into the second one just because there's less going on there. So 3, instead of times x, I'll do 3 times 4 because x is 4, minus y equals 9. I've now got 12 minus y equals 9. Subtract 12 from both sides. Boom. Negative y is equal to 9 take away 12 is negative 3. If it's negative y equals negative 3, I know that means that y is going to be equal to positive 3. So my final solution here should be 4, 3 as the location that these two original equations would intersect. And that's the solution to my system. All right, so that was a little do now review. Let's come back over here and actually get going on to the lesson itself. So we're going to be looking at reading and analyzing word problems and then creating the system of equations that we need to be able to solve and then actually solving them. So let's, whoops, what's going on there? So let's, there's two types, and I might do them in two separate videos. There are two types of systems of linear equation word problems. In both, it's really, really, really important to write let statements just so that you stay like aware of what's going on in the problem. These start to get more and more complex, and it stops becoming the type of question you can do entirely in your head, which is what this whole algebra method is for. So we're going to use let statements, and we're going to define each variable in the context of the problem just to stay organized. In the first type of problem, we're looking to solve for something specific, but we know two pieces of information about what we're looking for. One is typically how many of each. This type of problem I like to kind of call a value and amount type of problem, and you'll kind of see what I'm getting at when we as we start working through this problem. So, example number 1. The owner of a movie theater was counting the money for one day's ticket sales. He knew that a total of 150 tickets were sold. Adult tickets cost $7.50 each. $7.50 each. And children's tickets cost $4.75 each. If the total receipts for the day were $891.25, how much of each kind of ticket were sold? Okay, so first of all, let's start looking at like what were we even trying to look for in this problem, right? So that we can define our variables. It's asking how many of each kind of ticket were sold. Well, I know that there are adult tickets and that there are children's tickets, and I want to know how many of each kind of ticket were sold. So that's going to inform us on what I'm going to start writing over here. For the x, they don't say, so I'm just going to say x is, let x equal the number of adult tickets, and then I'm going to let y equal the number of child tickets. Next, we need to decide what two measurements we have in the problem about the tickets. And now this is where, this term measurements might be a little confusing, but this is where I bring in this value and amount type of question. For these types of questions, you're usually going to have an amount, a total amount of all the things all together, and then a value for them. Oftentimes, it's how many cans of, lemonade and bottles of water were sold all together and how much money, how many adult and child tickets and how much money. But you can also have, how many total hamburgers and hot dogs were sold, and then also the weight of all of those, right? It's an amount, just the total count of how many were sold, and then some value that changes more than just by one for everything. Okay, so if that was confusing, let's just start getting into it. My first equation, I always like to have my first equation be my amount equation. So I'm going to write my amount equation as saying, all right, well, there were a total amount of 150 tickets sold. So I know that my total is going to look like 150 and set that equal to, well, I have adult tickets at $7.50 each and children tickets at $4.75 each. But when I'm just looking for the total number of tickets sold, that money has nothing to do with just selling 150. All I know is that X is the number of adult tickets and Y is the number of children tickets, and the total number of tickets sold was 150. So I could just say, well, the 150 tickets total is going to be X, the number of adult tickets, plus Y, the number of children tickets. My second equation I like to have as my value equation, though the order doesn't really matter. And in this second equation, I need to get some space because I'm moving on to the next page. Let's just, boom. Okay. In this second type of equation, I'm going to put my value total. So the value total was $891.25. So my value total is $891.25. And that's going to be equal to something to do with my X and something to do with my Y. Well, this is $891, and I know that the adult tickets, they cost $7.50 each. So I can say, well, $7.50 per adult ticket times X, and I'm going to add that to the $4.75 each per child ticket. So here's kind of the general way it always goes. You have an amount for this type of question. This is one of the ways you do systems of equations. You have an amount, which is just the total amount of things sold or bought or whatever. And that just almost always goes with just the x and just the y. Then you have your value, the cost, the amount of money, the total number of pounds, whatever it is that, one thing has to multiply by some value amount, right? It's $7.50 for an adult ticket. It's $4.75 for a child ticket. So you have your amount total, which is just a number, x and y, and your value equation, which is money or some other value amount with the numbers multiplied that you got in your equation. So we'll see another example of it as I go faster and stop explaining it more. It might actually make it easier to understand. But let's actually just get into, now that we've set up the equations, let's get into solving this, right? So I'm just copying this down on my paper to the side before I scoot over. $7.50 x plus 475 y. And right now, here we go. We can solve the systems of linear equations. Now, if you've got a calculator, feel free to try solving this here, right? We've got decimals, so there is a chance that it might end up as a whole number. I'm just going to do it algebraically because we're still practicing that anyways. Okay, so I have my 150 x plus y, 150x plus y, and then 891.25 equals 750x plus 475y. Now, for this type of system, you're going to use whichever one you prefer at this point, right? Solving by elimination or solving by substitution. For this one, you know what? I'm going to show you that even with decimals, that elimination is okay. So what we're going to do is, it's okay. They're not totally lined up perfectly at the moment, but that is absolutely okay. So what I'm going to do, hold on, it seems like the video is kind of lagging. Sometimes it does that. Let me just come back over here, come back over here. Still kind of laggy. 2 more seconds, I'm sorry. That is a lot better. Okay. But I do have, sorry, so they're not perfectly lined up, but that's just because I drew it wrong. What I'm going to do is decide which one of these two to get rid of. I'm going to get rid of, this is about to get ugly because I'm doing elimination method. But, that's how it goes. I'm going to get rid of the y's. I don't know why, just that's what I'm going to do. Okay, so this is a positive 1y and a positive 475y. So I'm just going to multiply this entire top side by negative $4.75. And that is because I know once I have a negative 475y here, those y's will be ready to cancel. Now, I'm absolutely going to need a calculator here because these decimals are just going to get kind of bonkers. So let's just hop to it, right? Negative 475 times 150 is going to be negative 712.50 equals, and now I'm going to, negative 475, well, it's just negative 475x, and then that last one, negative 475y. And now, yeah, we've got some decimals, but actually, this is looking pretty easy now that I did this distribution. These guys are ready to cancel, and I can just add straight down my two equations. So, again, using a calculator because I don't, whatever, that's too much. 891.25 plus a negative, so I'll just say minus 712.50, and that's going to end up as 178.75. Set that equal to, these guys canceled, so I just need to do this 750 minus 475. 750 minus 475, 475 is going to be 2.75x, and we're almost there. I'm just going to divide both sides by $2.75. Cancels out. Divide by 275, and again, using the calculator, 178.75 divided by 275 ends up with 65 is equal to X. So now I know, because X is the number of adult tickets sold, that there were 65 adult tickets. But that is not the end of the problem, because I want to find out the amount for each type of ticket. So I can take this X and plug it back into either of my original equations. Clearly, this first one's going to be quite a bit easier because there's none of these decimals. So I'm going to rewrite this first one. 150 equals X plus Y, right? The total number of adult tickets plus children tickets makes 150 tickets sold. There were actually 65 adult tickets, so I'm going to say 150 is equal to 65 plus Y, and it's going to be really easy to solve for Y at this point, right? Minus 65, and now we've got 150 take away 65. Sorry, don't judge me, 85. So 85 is the number of children tickets, 65 is the number of adult tickets. And, let's just finish that over here. So solve it, and I can just say at the end of this, there were 65, right? 65? Yeah, 65. And I said that X was adult tickets, and X was 750. Yeah. 65 adult tickets sold, and 85 child tickets sold. I know this video is going on for a little while, but let's just get through the second example, and then I'll make a different video after that one. Okay, so this one is still that first type of question, but instead of using money, they're using pounds. It's still an amount value type of question. So let's read through it. Example 2. A group of 148 people are attending 5 days at a summer camp. The cook ordered 12 pounds of food for each adult and 9 pounds of food for each child. A total of 1,410 pounds of food was ordered. What was the total number of adults and children at the camp? So this again is a amount and value question. The amount is just the total number of people that were there, right? There's 148 people there. Some of them are adults, some of them are children. Here we've got our value, right? Our value is always the multiplier thing. Usually it's money. In this case, it's pounds. It was 12 pounds of food for each adult and 9 pounds of food for each child. So my second total is 1,410 pounds. That is my value total. So let's get into it. Let's say let X equal the number of adults, and then we'll let Y equal the number of children. And you know what? A lot of times I like to, instead of using X and Y, I might just say let A equal the number of adults and C equal the number of children, right? You don't need to necessarily be using X and Y. And sometimes it makes it easier to follow along if I say A, and as I'm going through the problem, like, oh, A is adults, instead of having to look back. But whatever, I'll leave it as X and Y for this. So, like I said before, I like to start with my amount equation first. The amount equation is just the total number of people. There are 148 people, so it's going to be 148. And the amount equation is always just going to be the total is just the total number of adults plus the total number of children. So it's just always going to be X plus Y. Your amount equation is nice and easy. Find the one that's not multiplying, and it's just the variables. Your value equation is slightly, there's slightly more going on, but it's not crazy. My value total the second total is 1,410, and that's going to be equal to 1,410. That's going to be equal to, and you just look at the multiplier. It's 12 pounds of food for each adult, so that's going to be 12x, and then 9 pounds of food for each child, so that's going to be 9y. I'm going to go ahead and copy these two onto my paper over here. 148 equals x plus y, and 1410 equals 12x plus 9y. All right, 148 equals x plus y. 1,410 equals 12x plus 9y. Now, I'm tempted to do this one by substitution, just for those of us out there that like substitution more. The thing is, though, is like, I feel like elimination is almost always cleaner, and I'm already running long on this video. So I'm going to do elimination again. I'm sorry. I'm going to choose to eliminate the y's again, just because that's a smaller number. That's usually a nicer one to eliminate. So I'm going to multiply both sides by -9, and that will get this y to be a -9y, and they'll be ready to cancel out. Let's get this multiplication going. Shoot, the video's lagging again. Let's come back over here, let it think again, come back over here, still lagging quite a bit. Oh man, I gotta close some applications on my computer. Yeah, that's a little better. Okay. Let's get to it. So -9 times 148 is going to be -1,332. That's going to equal to -9x minus 9y. This is what I wanted to set up so I can eliminate. Those will go away, and we're going to add these two equations straight down the line. 1410 minus 1,332, right? Plus negative is just the same thing as minus. I end up with 78 is equal to 12 take away 9, 3x. Divide both of those sides by 3, and I end up with 78 divided by 3. 26 is equal to x. That's going to be the number of adults. And I'm going to go ahead and plug it back into, again, this first one just because it's a bit easier, right? 148 equals, instead of x, I'm going to put 26 plus y. And then subtract 26 from both sides. That's going to end up being 122 is equal to y. So at the end of this problem, we can see that there were 26 adults and 122 children. And let's just, finish up this by saying, what was the total number of adults and children? There were 26 adults and 122 children, because we said x is the number of adults, y is the number of children. There were 26 adults and 122 children at the camp. That was a long enough video. Next time, we're going to look at the other type of systems of equations word problem, and we'll see a couple more examples that I'll give you a chance to try out.